maybe?
I need to do that.
Oh gosh, that's so good.
Okay, this problem says give exact answer. So giving exact answers means we leave logarithms or whatever happens to happen. We leave it alone. Exponentials, we leave it alone. What would y'all like to do with this problem?
Combine,
How and why?
because you're adding the logs.
Okay, so here I have a sum of logs. A sum of logs can be written as a single log. That would be written as log. They're both positive, so they're multiplied together. 3x plus 2 times x minus 1. From here, we can either use bases and make those exponents, or we can use definition to convert a logarithmic expression or logarithmic equation into an exponential equation. What's the base?
E. No. Wait. It's 10.
10. This is a common log, so the base is 10. What's the power? 1 equals the thing.
That big equation.
Okay. And now we have a very basic first semester Algebra 2 equation to solve.
Wait, where did the 10 to the 1 come from?
Base is 10.
Base is 10, power. It came from this. Log, base, thing, equals power. If you have that, you could rewrite it as base to the power equals the thing.
Okay.
Okay?
So is the thing just your terminology, or is that like?
It's my high-tech vocabulary.
Why can't we use
I
those?
was doing the homework in 4-5 and like we were doing like the natural log of this and it wasn't that log and they didn't like include like a base.
The base in natural log is e. See, we will never write. We don't do this. We don't do log base e of x. We don't write that. That is the exact same thing as natural log x. They mean the exact same thing.
So wait, log,
Does that help?
basic E is the same thing as
Do what?
natural base or natural?
Yes.
Okay.
Yes. Okay, so this needs to be FOILed. First times first.
3x squared.
3x squared.
Outside times outside.
Minus 3x.
Inside times inside.
2x.
Plus 2x. Combine those.
Negative 1x. And negative
Minus
Last times last
negative 2.
equals 10. Looks like a quadratic. To solve a quadratic, you set it equal to 0. To set this equal to 0, we need to subtract 10 from both sides. Subtracting 10 from both sides gives us 3x squared minus x minus 12 equals 0. To factor that, you need to figure out what AC is. What is A times C for this problem?
It is negative something. Negative.
Negative 36. Are there two numbers that multiply to get negative 36 but combine to negative 1? Is that possible?
No.
It's not possible. The only ways of getting 36 are 1 and 36. That's a nice 6. I did that earlier today too. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. That's it. That's the only ways to get 36. And none of those can give you a negative 1. So this is not factorable. So if you have a quadratic that's not factorable, you have two choices. We can complete the square. Any voting on completing the square?
No.
That fails. Quadratic formula?
Yes.
All right,
Yeah.
quadratic formula.
X is equal to negative b plus b squared b squared c all over two.
Okay. A is,
A is 3,
okay, B is,
-1,
C is,
-12.
discriminant, B squared minus 4AC,
B squared is 1.
-1 squared minus 4 times 3 times -12.
Let's do negatives to be positives.
1 plus 144 is 145. Are there any perfect squares that go into 145? I'll save you. No, there's not. Okay? So, x is equal to negative b. Well, b is -1, so -1 would be
1
1
plus
plus or minus the square root of
145.
-5.
all over
All over
Six.
6.
6. Okay? Two possible answers. When you're doing your homework, you check all of your answers. I'll just tell you the ones that don't work. We'll check it. The one I want to check is the negative part. If x equals 1 minus the square root of 145 over 6, give me an approximate decimal equivalent to that.
12 point.
Well,
No.
so like, no, it won't be 12?
It's not 12.
Would it be less?
It's a lot less than 12.
Oh, wait, never mind. My bad. I was doing just 145. I want to talk about it.
Wait, like type the whole thing in calculator?
-1.8.
Okay.
Good enough. Okay. So one of my answers is approximately -1.8. If you go back up to the original problem,
You can't have-
-1.8 times 3.
Can't have a negative.
It's a negative number. That's bigger than 2, right? So that right there would be negative if you plug the -1.8 in right there. So we got the log of a negative number, can't do that. Plug a -1.8 in here,
That's too much.
and it's still negative, right? Can you take the log of a negative number?
No.
No. So as we test our answers, we find out that this answer is no good. The other one's good. So our final answer is 1 plus the square root of 145 all over 6. The original problem says give the exact values. So because it says give exact values, you must leave it in radical form. Okay. Questions or comments on this one? Screenshot it if you're doing it. I'm going to the next problem. Natural log of e raised to the natural log of x power minus the natural log of x minus 3 is equal to the natural log of 2. Yay. Go, do it.
Funny joke.
One step at a time, baby steps.
How many exactly?
You ready to sit down? Working this problem.
Well, my notes.
Yeah, I just don't know where to start.
No.
Wait, so is E
Okay.
the thing?
Oh, wait.
Dude,
Do it.
On the first part, is E the thing?
It's the natural log of e, but that e is raised to the natural log of x power. That's what I would do. Absolutely. Okay, I've got one person that's got the very first step going.
Hey,
He wasn't talking about me. No,
that was funny.
Thank you. Okay, remember, look at the different pieces of it, see if some of the pieces, if there's something you can do with it to simplify something.
How, I know, can you do that thing where you can square it and then it cancels? No.
You can't do that yet.
That was upsetting.
Quit throwing stuff at me.
Am I getting somewhere? Or just making up my own math again?
You're getting somewhere, Hannah.
Well, I mean, you haven't violated any laws.
Well, like math laws or like
I mean-
legal laws?
As I look at what you're doing, I follow your logic. I didn't work it this way. But that doesn't mean.
What is that supposed to
That
mean?
doesn't mean anything.
I didn't work it this way.
So if we got rid of those, because if you take that of that, and it's equal to that of that, then this piece and this piece must equal, right? So next line item without those pieces.
Wait, can I move
And
this
tell me
in
what
front?
you're gonna- And you keep going, see what happens. I don't know. I would not have done it that way.
Can I move this in the front?
Why?
Because that's the thing that you, right?
Because it's what?
No, it's not the base. That's
The next line.
it's the exponent, so you move it to the front.
Sure, do-
Are you sure?
that's the way I did it.
Yes.
From what I
Yeah, I didn't
heard.
really what you did. I'm very confused.
You're taking the natural log of that thing,
Oh, yeah,
okay?
Yes.
That's what I did.
What do you got going?
Wait. Shit, I don't even know. Can you divide?
I'm curious to see this method over here.
I don't know where to go now.
Wait, so do you now divide?
Get rid of your denominator, multiply both sides by the denominator. Okay, so that's gonna help someone.
I'm stuck again.
I got the first step.
It'd be a lot easier if I went your way. What?
So, I got that.
Guys, I got it.
Do I divide by that one or that one?
What is that?
That's what I need.
What is that? What's the value of natural log?
One.
Oh, this is
You
right.
gotta get X by itself.
That is,
No, you got X over here too.
I know. I just realized that.
I didn't know what I was doing, that's why I gave up, but I just noticed like when Harry, when he was recently.
No.
Sort of law.
Where do you go first?
No, because that's not just
The
E.
first step.
So that natural log is there.
That's it.
Okay. I've got one correct answer so far.
Oh.
Yay!
I've got two correct answers so far. So like opposite sides of the room. Two totally different methods.
Is Hannah's method easier?
That's a no.
Okay.
Is it the thought
I don't know.
process or the method
I don't
that's
know.
easier?
I'll do it our way. And you tell me if you think your way's easier.
Okay.
Okay, if I'm taking the natural log of something, what can I do to the exponent?
Move it.
Exponent comes out front. So I've got natural log of x. What's the natural log of e?
Cancel.
1,
I was just kidding.
Oh.
okay? Minus natural log of x minus 3 equals natural log of 2.
I never would thought to do
Yes. I'm gonna time it. Okay, wait. Just count it. Okay, I have a difference of logs. What can I do with that?
Combine.
That is a single log. Positive one goes on top, negative goes on the bottom. So I have natural log of x over x minus 3 equals natural log of 2. How can that be true? How can the natural log of one thing equal the natural log of another thing?
If x over negative 3 equals 2.
If the things are the same,
What?
right? Multiply both sides by x minus 3. I get x equals 2x minus 6. Subtract x from both sides. Add 6 to both sides. X is 6. You did it another way. Which way is easier? Or are they the same, essentially the
For
same?
me, mentally, I would have gone my way. Well, that because I did, but like because the last problem is using the same one.
How
it's
does
my
x
way.
equal 6 if there's a 2?
2 times 6 is? Work with me here. 2 times 6 is?
12.
Minus 6 is?
6.
6, okay. Hannah took this and wrote that as a single log. So she wrote natural log of e to the natural log of x.
Yeah.
That's pretty awesome. Over x minus 3 equals natural log of 2. She then has e to the natural log of x.
Woohoo.
I'm talented.
Apparently.
Over x minus 3 equals 2. Multiplying both sides by x minus 3, she gets e to the natural log of x equals 2x minus 6. And what you said a while ago, now can I do it?
Yes.
Okay. What is e to the natural log? Essentially it cancels. So I have x equals 2x minus 6. X equals 6.
2 times 6 was 12 minus
Okay. Yeah. I don't know. I would have never done it the red way.
Did you just invent
That's how I thought. That's how I tried doing it, but I lost. I didn't know how to do it after the third, or after the second.
Yeah. I mean, we're all applying the same properties of logarithms, right? We're just applying it at different times in different ways. As long as you check it to make sure it works, there shouldn't be a problem here.
Interesting.
That was the last one, right?
Oh, we have word problems left still too.
Oh, my goodness.
Guys, I'm gonna get a screenshot here. These are the steps we use to solve exponential or logarithmic equations. This is what we do every time. If you have a to some power is equal to b, to get that power down, you take the log of both sides. Taking the log of both sides brings the exponents down. If you have the log of a function is equal to b, how do you get rid of a log? You can change it by definition, or make that a the exponent, then it cancels, and you still have the exact same thing anyway. If the log of one function is equal to the log of another function with the same base, that can only be true if the functions are equal. And sometimes we have to simplify first. 2-word problems. Since the strength of a habit is a function of the number of times a habit is repeated, if n is the number of repetitions and h is the strength of the habit, then according to the psychologist C.L. Hull, the habit is equal to this function here. K is a constant. Our directions here are to solve the equation for k. That's a mess.
Yeah.
And our goal is to get k by itself. I wasn't responsible for teaching any of you algebra. I'm going to go ahead and walk through this problem as if I'm teaching an Algebra 1 class. And I'm going to show you the process that I go through. Our goal is to get k by itself. So to get k by itself, what I want to do is I want to make a list in order of what happened to the k. What happened to the k? So look at the k. Back off just a little bit from the k. What happened to the k?
It's getting multiplied by n.
It's multiplied by n, but it's multiplied by something else too.
-1.
Okay, can you see that k is multiplied by negative n?
No. Oh yeah, you can.
Right? Okay, so the very first thing that happened to k is it was multiplied by negative n. Have y'all ever done anything like this before, like I'm doing? Nope. Making a list? You've done this before? You've done this before? Okay.
Oh wait, no, we did do it in this document.
Okay. Now what's done to it? Back away from it. Uh-oh. What happened to the k?
It's up B to the E.
Okay, the second thing that happened was it became exponential. Then what happened to it?
The exponential was subtracted.
Because it was multiplied by a -1,
Wait, what?
right?
Okay.
So I've got a k, I multiplied by negative n, I got negative k to the n. I made it exponential with e to the negative kn. Now e to the kn became negative. How did that happen? It was multiplied by -1. Then what happened?
Subtracted.
It's not subtracted.
I mean, it's
The 1 was added,
yeah.
right? So we added the 1. Then what happened?
Multiplied by 1,000.
Anything else happened to the k?
No.
No.
That's it. So this is all the stuff that happened to the k. How do you get rid of all this stuff?
Do the opposite.
Okay. Go backward to get x by itself. All right. Number 1.
Wait, X or K?
I'm so used to variable being x. Thank you. Okay, so I need to start at the bottom. I need to undo multiplying by 1,000.
Divide.
Divide both sides by 1,000. So I have h over 1,000 equals 1 minus e to the negative k n power. Step number 2. I need to unadd a 1.
Subtract one.
You gotta subtract the 1.
H over 1,000 minus 1 equals negative e to the negative k n power. Step number 3.
Can't you remove the negative signs?
Okay, so I need to unmultiply by negative 1. So how do you unmultiply by negative 1?
Divide.
You either divide by negative 1 or multiply by negative 1 again. Right? Which means change the signs.
Yeah.
Okay, so it becomes, instead of a negative 1, it's going to become a positive 1. Instead of a positive h over 1,000, I have a minus h over 1,000 equals e to the negative k n power.
Whoa.
Step number 4. It became exponential. How do you undo exponential?
Log,
But because we're base e, we're going to do
natural log.
natural log. I will take the natural log of both sides. So natural log of 1 minus h over 1,000 equals, when you take the natural log of e, what happens?
It turns into 1.
Cancels. I've got negative kn. And step number 5.
Get rid of n.
I need to unmultiply by negative n.
Divide by
Divide by
Negative.
negative n.
yeah.
Or multiply by negative 1 over n, because it's the same thing. So I'm going to multiply this side by negative 1 over n. I'll divide this side by negative n. The negative and the n cancels. So k is now by itself. K is equal to negative 1 over n, natural log of 1 minus h over 1,000. Now, if you had written that as negative natural log of 1 minus h over 1,000 all divided by n, that would be fine too. It's just ugly having fractions within fractions.
Can I fit?
Okay, that's what k is. That's what it said to do, right? It said get k by itself. Guys, this is basically algebra 1 problem. The only difference is the exponential piece. How do you unexponential it? By taking the log. And last question has 2 parts. Table gives you as tablet cells in millions for several years. The data can be modeled by the function, and he gives you a lovely function there, where t is the number of years after 2009. Part A, use the function to estimate the number of tablets sold in the United States in 2015.
Can you plug it in? Exactly.
Will we use the average?
I don't know. What do y'all want to do?
Put that into the calculator and then get.
Are we looking for a t value or are we looking for sales?
So,
We're looking for sales.
So can't we just plug both of those, like the 2010, 2011, 2012, and then simply be 2.4 all that into the calculator?
Why are you doing that? It's already given us the equation.
Because wouldn't it give you 2015 and then only go?
Yeah.
No?
Not necessarily.
Or would you plug 2015 in for the?
Let me ask you that. Would you plug 2015 in for t?
No. I don't know. I thought you would because
Well,
I'm so confused.
exponential.
Huh?
6.
6. What's 6?
The number of years
T.
after 2009.
T is 6. What does it say t represents?
The number of years after 2009.
Okay. If t is the number of years after 2009, when does 2015 happen?
6 years later.
6 years after. So all this question is asking us is what is f of 6? $20.57, natural log of 6, plus 10.58. And you just type that in the calculator.
Um, 47.4. Huh?
47.43.
Why did you shake your head at me?
Because I tried to draw a 4 and it wasn't working, and then a Y shot up on the screen. I didn't know what it was doing. Okay. What does 47.4 mean?
That's the
That's the
number of
Probably
estimate
millions of cells.
of the number
Okay.
of cells.
Okay. So who's planning on taking stats possibly next year or the year after? Okay. This is a stats question. To answer this question, you would say, based on the data, we would predict that the cells in 2015 would be 47.4 million tablets,
Do you have to write that down?
based on the data. It's a word problem, you should answer it with sentences, right?
Uh-huh.
I told you that's in the beginning of the year. You see a word problem, you should answer it with a sentence. So
Except on the star test.
based on the data, we would estimate there were 47.4 tablets sold in the United States in 2015. Okay?
So 47.4
Million.
million.
Based on the data, we could estimate that the number of tablets sold in the United States in 2015 is 47.4 million.
Well, that wasn't so hard, and that's a stats question.
I mean, it's just coming off the data and answering a data question. Next question. If this trend continues, when will cells reach 60 million?
Now can you put it in the calculator? No.
Don't need to.
What?
Well, you need to divide.
What are you trying to do?
You are trying to find T note.
1/60 for T.
So you're wanting T to be 1/60?
No.
1/60th of a year since
Oh, yeah.
2009? That's silly.
Equal to 60 and so for T.
We're solving for T.
That's
So-
what I said.
The previous problem, they gave us basically in a roundabout way, they gave us T. We plugged T in to find the cells. Now they're giving us the cells, we gotta find T. So they have given us F of T. They're telling us that F of T is 60. Don't be like fourth grade and write 60 million equals. No,
What?
no, it's just 60 equals.
I tried 60 million.
Because it says 60 million right there.
20.5.
Okay, I need to solve for T. What should we do first?
Minus 10.58.
Okay, 60 minus 10.58 would be 49.42. Next step,
Would you subtract 20.57?
only if it was added.
Divide it.
Okay,
So multiply? Oh, okay. So yeah, divide.
okay, now listen to this. Yes, you are going to divide both sides by 20.57, but don't do it. Do it, but don't do it. Meaning don't do the math.
Cause it's gonna get
Okay,
bigger than.
Because if you did the math, you'd be rounding. You're just gonna keep that number going forward. So if I divided both sides by 20.57, I would get 49.42 divided by 20.57 equals natural log of T. We can either use definition or use exponents to get T by itself.
Exponents.
Okay, what's the base?
E.
So both sides we have e to the right?
And then it cancels.
This is
Cancel,
gone,
that equals T.
so this is T. That you'll put in the calculator. Then you give me an answer. Do you see the difference? How we carried this math forward to put it into our final step.
It's 2.4.
I was thinking it was like 2.05 rounded. Is it 2.05?
I did not get that.
I got 2.40.
I got like 11.
Yeah, I got 11 something.
I typed in E.
Oh yeah, it is 11.
That's 11.
Oh yeah, I forgot the E.
11.05. Yeah.
Oof, I was just
We
saying
did
that.
it right, Andrew.
Okay, what does that mean?
That
Based on the data.
Based on this data,
the sales the annual sales will reach 60 million in 2020.
in 2020. 2020. Add 11 to the 2009, you get 2020. Based on the data, we would expect to hit sales of 60 million tablets in the year 2020. And then COVID hits, so a lot less than that. I don't know.
Wait, we'll expect to hit sales what?
Of 60 million tablets.
In 2020?
Yes.
But of course it hits.
Okay, stop the recording real quick, and then I'll chat for just
Second.
And we're done with all units until the review.